In this video, we'll be covering straight line graphs, how to find the equations of straight line graphs, and what the equation of a straight line graph tells you. So every straight line graph can be written in the form y equals mx plus c. Having the equation of a straight line graph in this form helps you for the reasons we're about to cover now. So when your straight line graph is in the equation y equals mx plus c, we have y and x as our variables. So we know that these are our variables. Now m and c are constants, which means that they take particular numerical values. And these are fixed values which we need to find. So m is our gradient. Now what this means is the steepness of the graph. Now c is called our y-intercept. All this is where the straight line crosses the y-axis. So we'll cover how to find the y-intercept later on as well. Now, to be able to find the gradient of a straight line graph, you need at least two coordinates. And to find the y-intercept of a straight line graph, you need one coordinate and you need the gradient. So given that you need the gradient to find the y-intercept, you're going to need to find the gradient of the straight line graph first. Now let's take this straight line graph for example. So as we mentioned before, we need two coordinates to be able to find the gradient of a line. Now keep in mind that you won't always be given a graph for you to find any two coordinates of your choice. You might just be given the two coordinates to work with. And we'll go through both examples. So for this one, we'll be using the graph to find two coordinates and find the gradient of them. So let's pick this coordinate, which is 2, 6. And let's pick this coordinate, which is 5, 12. Now, the equation of the gradient is change in y over change in x. So we need to see the difference in our y coordinates and the difference in our x coordinates. So I'm going to draw a triangle to illustrate this. Now that we have our triangle, we can see that we've gone up from the y coordinate 6 all the way up to the y coordinate 12. So the change in y is 6. And we can also see that we've gone from our x coordinate of 2 up to our x coordinate of 5. So the change in x is 3. So our gradient m becomes 6 over 3, which is 2. So as we said earlier, we need our gradient and a coordinate to be able to find our y-intercept. However, in this case, because we have our graph, we can simply read the y-coordinate by looking at where the line crosses the y-axis. And in this case, the line crosses the y-axis at the point when y is equal to 2. So c is equal to 2 in this case. Now that we have our gradient and we have our y-intercept, we can write our equation of the line. We know that our equation of a straight line is y equals mx plus c, so we can replace the m with 2 and c with 2 also. So the equation of this line graph in particular is y is equal to 2x plus 2. Now, let's take a look at an example where we are given two coordinates and we are told to find the equation of the line that goes through both of these coordinates. And in this case, we're not able to choose our coordinates, and we're also not able to read off the graph to find our y-intercept. So we'll have to do a little bit more work. So to find the gradient, we do the same thing. The equation is m is equal to change in y over change in x. This means that we need to decide, are we going to do coordinate b minus coordinate a or coordinate a minus coordinate b? So for this example, I will pick coordinate b minus coordinate a, but you can do whichever one you'd like. You will get the same answer either way. So if we're going to subtract coordinate a from coordinate b, we will have the y-coordinate of b, which is minus 3, minus the y-coordinate of a, which is 3, over the x-coordinate of b, which is 4, minus the x-coordinate of a, which is minus 2. So this way we're finding a difference in the y-coordinates and the x-coordinates. So minus 3 would be minus 6, and 4 minus negative 2 would become 4 plus 2, which is 6. And we know that minus 6 over 6 is negative 1. So our gradient of the line is going to be negative 1. And just like before, because we have the gradient of the line, we can find our y-intercept. And how we do that is to substitute it into the equation y equals mx plus c. So because we know our gradient, we can substitute that in. So we have y is equal to minus 1x plus c. So to be able to find our y-intercept, so our c value, we need to substitute one of our coordinates into y and x so that we can find c. You have a little bit of freedom here because you can pick whichever coordinate you'd like. In this case, I'll pick coordinate A. So I'll substitute the y coordinate of A into y, which is 3, and the x coordinate of A is negative 2 into x, and plus c. So if we rearrange this equation to find c, first we expand the brackets. So we would get 3 is equal to 2 plus c. And now if we rearrange the equation, we find that c is equal to 1. So now that we have our gradient and our y-intercept, we can rewrite the equation as y is equal to negative 1x plus 1. And that is how we find the equation of straight lines given two coordinates.